Aromatic derivatives nomenclature. Let's have a quick look at the classification chart. We're looking at this area, benzene, and its derivatives. There are three parts to this. We'll start with part A. We simply name the substituent as a prefix to benzene. So, for example, here we have chlorine on a benzene ring, so it's simply called chlorobenzene. In this case, we have the nitro group giving us nitrobenzene. And here we have the amino group, so this would be called aminobenzene. Certain compounds are known by their trivial, which means common, names. You should know some of these. This one, methylbenzene, is better known as toluene. It is a colorless liquid like benzene. Methylbenzene is still a correct name. Aminobenzene is also known as aniline, or aminobenzene as above. It has a long history as a precursor to many dyes. BASF, a company in Germany, was one of the first to start this large and important industry. The A in the name stands for aniline. The title page showing those bright colored materials contains some combinations that contain aniline or aniline derivatives. This hydroxybenzene is called phenol, or hydroxybenzene. Finally, you should know this one as benzoic acid. If you're taking biology, you already recognize the carboxylic acid group that can also be shown like this. Now part B, positions on the ring. If there are two groups, we can indicate their positions in an interesting way. First, consider R that represents any atom or group. Look at these three positions. They're all relative to R. If the substituent is right next to R, one carbon away, it's in the ortho position to R. In this position, it is meta to that group, and in this position, it is para. Substituents can also be on the other side, like this, which is ortho, one carbon from R, and this, meta, two carbons from R. Now we can call this first one ortho-dibromobenzene. Ortho for the relative positions, and the prefix di to indicate the two bromines. This could also be called 1,2-dibromobenzene. If you see it in this position, you recognize that it is also ortho-dibromobenzene. In the next one, you can see that this would be the meta-dibromobenzene, or 1,3-dibromobenzene. It could also be shown this way. This one shows chlorines para to each other, so para-dichlorobenzene. Also 1,4-dichlorobenzene. This molecule has an interesting real-world application. It is the main ingredient in mothballs. The ingredients shown here, hard to see. There it is in English and French. Para-dichlorobenzene 99.9%. So essentially pure para-dichlorobenzene. Another ingredient in mothballs you may be familiar with is this one, naphthalene, which are two benzene rings fused together. Now, if you have different groups such as this, iodine and bromine, you can see they are para to each other. Which substituent is named first? We follow the simplest idea, which is to name them in alphabetical order. Bromine comes first, so we name it para-bromoiodobenzene. In this one, we have a nitro group and a chlorine group. Chlorine comes first. It is meta to nitro, so this would be metachloronitrobenzene. How would you name this one? We have methyl and nitro in the ortho position to each other. Methyl comes before nitro, so we would name it orthomethylnitrobenzene. How about this one? It's the same molecule with methyl and nitro ortho to each other. But this time, let's cover up the nitro group and recognize that we have the trivial name toluene. With nitro in the ortho position, we can name this ortho-nitrotoluene, and it could also be named 2-nitrotoluene. In this one, if we block out bromine, you recognize that we have phenol. So with bromine in the para position, we get para-bromophenol, or also 4-bromophenol. Here we recognize, without the nitro group, benzoic acid. With nitro in the meta position, we write M-nitrobenzoic acid. Also, 3-benzoic acid is correct. The final one here you recognize as a derivative of aniline. So this is ortho-iodoaniline or 2-iodoaniline. Finally, part C. If we have more than two groups, we must use numbers. Remember, we can number the ring in any way as long as the sum of the numbers is the smallest. In this example, we can't use the ortho-meta-para system because there are 3 substituents here and not 2. If we number them like this, we have 1,2,4-tribromobenzene. If we number it the other way around, we get 1,3,4-tribromobenzene. The sum here is 8 and 7 in the first one. So this is wrong. Here, we could look at this as a phenol or aniline. Let's start with phenol, which means carbon 1 would be here, and the other numbers take their normal root. We have chlorine on 2 and amino on 4, giving us 4-amino-2-chlorophenol. If we look at this again as a derivative of aniline, we start numbering here. And with chlorine on 3 and hydroxy on 4, we get 3-chloro-4-hydroxyaniline. Since 3 plus 4 is greater than 4 plus 2, the first one is correct. Consider this one as a derivative of toluene. Then either way we number it, it has nitro groups on carbons 2, 4, and 6, giving us 2,4,6-trinitrotoluene. This is a very unstable molecule, and this property has been used to form TNT, not dynamite, which is nitroglycerin. Finally, there is a special group called the xylenes. These are dimethylbenzenes, and there are only 3. It's a small group, but quite common, so good to know. This would be orthoxylene, metaxylene, and paraxylene. Of course, other names are also correct. 1,2-dimethylbenzene, orthomethyltoluene, 2-methyltoluene. In a similar manner, we have 1,3-dimethylbenzene, metamethyltoluene, 3-methyltoluene, and these 3 as well. Finally, here is some practice for you. You could stop the video, try them, and then come back and see how you did. Did you name this one 1-ethyl-3,4-dimethylbenzene? Unfortunately, it's wrong. Can you see why? Remember to number the ring to get the smallest sum of numbers. So starting with the bottom methyl group, you would get 1,2-dimethyl-4-ethylbenzene. The sum 7 is less than the sum 8. Almost there. Remember to order the groups alphabetically. The final name is then 4-ethyl-1,2-dimethylbenzene. We could also look at this as a derivative of toluene, and so name it 4-ethyl-2-methyltoluene. Here's the next answer: metamethylbenzoic acid, or 3-methylbenzoic acid. And here is the third one, 4-chloro-2,5-dinitrotoluene. Your structures hopefully look like these. Now, to explain why the following name is incorrect. According to the name, we have a methyl and two ethyl groups as shown here. The first correction is to alphabetize. Ethyl before methyl gives 3,4-diethyl 1-methylbenzene. But have we got the lowest numbers? Start numbering from here, and we get the final correct name, 1,2-diethyl 4-methylbenzene. This ends the video on naming aromatic derivatives.